Now we are going live. YouTube also. In US, if you are outside US, sorry, if you are 1 minute, a long time, and hence there are few issues, but that's fine. Now the issue is addressed. And then we'll get into the actual agenda. So whoever is in India, whoever is joining from other parts of the world, depending upon the time zone, it is either good afternoon or good night or good evening. So today's session is primarily to give overview about roadmap to become data engineer for ETL, PL, SQL, data warehouse, and mainframes developers. Let me open the deck and then I'll take it further. So even though I'm catering towards ETL, PL, SQL, data warehouse, mainframes developers, even if you are not belonging to that category of IT professionals, still there will be a lot you'll be learning in this two-part workshop. So this is part one of two-part workshop. Tomorrow at the same time, we have the second workshop. That being said, let me open the deck, then we'll take it further. Hear me clear. I have already validated. I'm able to hear myself earlier, and hence I think it should be fine. Now let me go into the slideshow mode. For this today workshop, introduction about ITversity. I'll just give a brief introduction about ITversity. Most of you might already be aware of it, but still I would like to share details about ITversity. Then about my expertise and journey. And the reason why I'm covering this, especially in this session, is because this is primarily for ETL, PL, SQL, data warehouse, and mainframes developers. I have a significant amount of experience on ETL, PL, SQL, and data warehousing before I get into the big data and data engineering. That's why I would like to highlight about my expertise and journey, especially covering those aspects. Then we'll actually talk about what is data engineering and why ETL, PL, SQL, data warehouse, and mainframes developers should take it seriously. What are the key skills and up to what level ETL, PL, SQL, data warehouse, and mainframes developers should know these skills? And also details about our guided program on AWS, especially to transition, to help in our transition towards data engineering using the cloud platform. Then we'll actually talk about details related to the program once we go through this thing. The fourth part is very, very important. What are the key skills and up to what level ETL, PL, SQL, data warehouse, and mainframe developers should know the skills? We'll be talking about a real world scenario, and I will demonstrate how to build a pipeline and what all skills that are required to build the pipeline. That will give a little bit of clarity around what you should be focusing on if you wanted to transition into a data engineer, especially from traditional data warehouse or ETL development background. That being said, make sure you subscribe to the channel if you haven't subscribed yet, and also click on the notification icon so that you will get notified whenever we upload the content. And also make sure you like and also share with your friends in case if anyone fall in this category, or if they're aspiring to be data engineers on cloud. You can actually visit our website. This is our website. You can subscribe to our YouTube channel by clicking on this link. This deck is there as part of the description. You can go to the deck and you can actually go to these links. You don't need to type these things. The same deck which is being presented, you can open on your side and you can click on these links and you can take it further. You can also follow our company page by clicking on this link. Also, you can sign up for our newsletter. So we'll be conducting quite a lot of workshops. We'll be sharing quite a lot of insights about what is going on in the industry and all over a period of time. And hence, you can sign up for our newsletter to get all updates. I'm also Udemy instructor. I have almost 200,000 plus students on Udemy. In case if you want to know more about my courses and me on Udemy, you can click on this. At any time, if you have any queries, you should be able to click on, you should be able to send email to support@itversity.com. Now, this is a special note to Udemy customers. First of all, thank you very much for being our esteemed customer. You might have to rate us and provide feedback. I'll also give a brief demonstration on this so that you are really comfortable about providing the feedback as well as rating. So I'm deviating from this deck and I'm logging into my Udemy account. go to My Learning. If you sign up for any course, it will show something like this. Okay, you can pick the course. Let me see if I have one of my courses here. I want to demonstrate using my courses. Not there, but yeah, let me pick this one. Let me pick this one and for complete beginners. In case if you like the content, you should be able to rate us directly from here also. You see here, there is a rating. You can click on this and you should be able to leave the rating. You can select the rating and also it will ask for the feedback. It is very important not only for raters but also to give the feedback. This is one way to give rating and feedback. And also, if you actually go to your course player on Udemy, you see here also there is a option to edit your rating. So you just have to go to top right corner, then click on edit your rating. Then you should be able to rate us and also leave the feedback. So these are the two ways where you can leave us the rating as well as feedback. Make sure you do that so that we get some traction to our courses. So just a special note for the Udemy customers. And once again, I thank you very much for being esteemed customers. Many of you might be aware of both our guided programs as well as Udemy. Some people are curious about what is the difference between Udemy and our guided programs. Those details will be clarified towards the end of this deck, towards the end of this workshop, which is tomorrow. So that being said, now introduction about ITversity. It started as a YouTube channel in 2014. As of now, it has 60,000 plus subscribers. At one point in time, it was growing at 1,200 subscribers per month. But as I moved on to Udemy and as I have reduced the focus on YouTube, the subscriber rate is not as good as it used to be. But still, I get 400, 500 subscribers per month. Yeah, in case if you want to be a subscriber, you can subscribe to our channel. There's a lot of content already. We'll be providing or publishing a lot of content in future also. And also we'll be conducting these live streaming sessions. One of the advantage of subscribing to the channel and clicking on the notification icon is whenever we have these live streaming sessions, you'll get notified. With Hadoop and evolved with the industry, at ITversity, we have expertise in these areas. Hadoop and its ecosystem such as Scoop, Hive, Flume, etc. But don't get excited with this. Hadoop ecosystem is already dead. We are in the final stages where existing Hadoop applications are completely getting away from there and they're getting into a more cloud-based solutioning. Okay. Anything related to Hadoop, whether it is HDFS, MapReduce, Hive will exist in a different shape, but Scoop, Flume, Pig, all these will be dying very soon. If you are focused on those areas, it's better to stop now and move on to data engineering using cloud and build the skills around the cloud platforms. As the industry evolved into Spark and Kafka, we have actually got into the Spark and Kafka content. Now the industry is more into cloud. So we'll be primarily focusing on data engineering on cloud going forward. Also, Docker and Kubernetes will have its own place in this world. And hence we'll be emphasizing on those areas as well in future. Also keep in mind that most of the services which are there in the cloud platform are built upon Docker and Kubernetes only, even though it is completely abstracted from you. Okay. So when it comes to our Udemy journey, we at ITversity, we have launched our first course in Udemy in 2016, but I haven't taken it seriously until a few months back. Only for past 13, 14 months, I have been consistently publishing courses on data engineering, and I'll continue to do so. At one time, it have grown significantly, but after that, it have came down because I haven't focused on Udemy as well. But now I'll be focusing on both Udemy and also guided programs along with YouTube. Our focus areas are nothing but data engineering on cloud using AWS, Azure, GCP, Databricks, Snowflake, etc. Now, let me go to the next slide. This will actually cover my expertise and journey. It is primarily to attract your attention as a ETL or data warehouse developer, because this is primarily a roadmap to become a data engineer for those kind of developers. And hence, there is a bit more emphasis on data warehousing terms, even though I am experienced in other areas. At this juncture, I'm primarily focusing on the areas which you are comfortable with. 3+ years of rich IT experience in building large-scale data-driven applications. Started a career as a trainee or intern in 2002. By the way, I'm a high school dropout, so I have failed in my intermediate and I got only 48% in intermediate. And since then, I even worked in a medical shop as a sales boy. And then I actually transitioned myself into IT professional. I think it is a destiny for me to be a IT professional, that to data professional. That's why from nowhere I got into the IT and data related areas. So started my career as a trainee or intern in 2002 in a company called as Paradigm Infotech. Then I started as an employee with Talend Technologies as Java developer in 2004. Then started solving complex data problems and moved to US in 2006. So at Talend, while serving a mortgage client, there were quite a few database related issues. I started solving those issues. I have rewritten complex PL SQL modules. And also I have solved quite a few performance tuning issues. It actually mobilized me to move to US. Means and the company sponsored my H1 and I moved to US in 2006. Then I have transitioned myself completely into PL SQL data warehousing and Golden Gate in 2007. Implemented quite a few zero downtime large-scale migrations, including large-scale data warehouses from Latin America into US data centers for a major financial client. Transitioned into big data in 2012 as a technical manager or consultant for Cognizant. Then I have served clients like Walmart. There are quite a few Fortune clients which I have served in the role of technical manager or consultant for Cognizant, and also as an architect in IBM. Then I moved back to India in 2015. Then started taking the training and IT university seriously. That's where I moved myself into the training domain. While training, I'm also very passionate about consulting. I continuously consult in the areas of big data and data engineering. So I'm a solid 20-year veteran in the data field, and I have traveled with the evolution of the industry in the past 20 years since I started my career. And the tech stack means almost everything that is related to big data, data engineering, I'm quite comfortable with, and I can still code for a very complex situation and provide the solution for the companies. Trained thousands of professionals across the globe leveraging state-of-the-art labs. We also have big data labs, which have Hadoop, Spark, Kafka, etc. So in case if you want to learn Spark and Kafka in a multi-node environment, you should be able to sign up for our labs and you can practice. We also have a course in our platform, which you can sign up and take it further. Even as part of the Udemy, there is a course which actually provide you the required content around Hadoop, Spark, and Kafka. Even though Hadoop is dead, still Spark and Kafka are relevant, and hence you should be able to learn Spark and Kafka. Now, let me get into the actual agenda for this session. This is primarily to provide roadmap to become a data engineer for ETL or data warehouse or PL SQL developers. First of all, you need to keep in mind that you need to transition yourself into data engineering. Data warehousing is being cannibalized by data engineering. And hence, if you don't transition yourself into the data engineering, and if you wanted to be hands-on technical person, then there'll be quite a few challenges to sustain at our current level itself. It is inevitable or it is mandatory or it is required for you to transition into data engineering role if you are a hands-on ETL or PL SQL developer. So this is the brief recap of conventional data warehousing. You will have databases like Oracle, where data is structured. Typically, they provide data in the form of queries, or they might even give you the data in the form of files. If the source system don't want you to get the complete control to get the data from source, they might generate files on regular basis, and they might give you the files or give your applications in the form of files. And you can actually consume data from the database and do whatever you want. and eventually provide in the form of reports. In that process, in the process of ETL, you might end up having ODS. ODS stands for Operational Data Store, where you will have the tables almost in similar structure as the source. Once the data is in ODS, then you build your ETL workflows or pipelines or mappings, whatever you call them, and the data will be eventually be ported into the data warehouse. In the data warehouse, you will be having your tables in the form of facts, dimensions, etc. Using the measures in the facts and dimensions, you will be able to provide reports and dashboards to the executors. This is the recap of conventional data warehousing. You might be implementing it via ETL tools like Informatica, Abinitio, DataStage, etc. Or you might be implementing using PL SQL. I have worked on ETL projects where PL SQL is extensively used. So these are the patterns which you typically follow when it comes to implementing data ETL solutions as per your report requirements. So now, what are your responsibilities in this process? You typically understand the reporting requirements and collaborate with BA developers or architects to come up with the data model. When I say data model, I'm talking about data model in this area. Okay. Then you ingest data from files, databases, etc. into ODS if ODS is required as per the high-level architecture of your data warehouse project. Then you perform ETL. As part of performing ETL, you extract data from ODS, apply relevant transformation rules, and then load into data marts. As part of data warehouse, you will be having quite a few data marts. These data marts are the ones which will actually used to serve the reports or dashboards using reporting tools. The reporting tools are nothing but Tableau, ClickView, etc. This is how the responsibilities are defined as an ETL developer. What are the tasks you typically perform? You develop ETL applications based on the requirements using tools. Those tools are nothing but Informatica, Talend, Abinitio, etc. You also build frameworks to get the data from source into ODS depending on ODS requirements. In the initial stages of my career, I have seen people struggle with Informatica and all to get data from sources into ODS, because when it comes to ODS, you have to deal with hundreds and thousands of tables, even though for your ETL, you just need handful of tables. In the beginning of my career, when they started using Informatica, Abinitio, or DataStage as the ETL tools, for each and every table, they were expected to create a mapping, which is not right. And hence, eventually, I'm also lucky in building one solution for a company in Austin, Texas, where we have built a PL SQL based solution to get the data from all the sources into ODS of the data warehouse. Once the data is in ODS, then we have used ETL tools such as Informatica based upon the reporting requirements to get the data into the dimensions and facts. So we might end up developing frameworks to get data from source into ODS, depending on ODS requirements. Typically, we need to use metadata-driven development approach to actually solve the problems like getting data from source into ODS. As of today, it is known as the data ingestion. So for data ingestion, typically we use metadata-driven development so that we don't need to deal with individual tables. Tools to export and import data for development and unit testing. So that is the another responsibility of ETL developer. Many times we might want to get data into tables to validate, to understand the data, to perform the unit testing and all. Right, so we need to be familiar about underlying database export and import capabilities, and we might have to use those tools to export and import into the downstream databases and do analysis, perform unit testing, etc. Also, as I mentioned to you, you have to run ad hoc queries against these tables, which are exported and imported to understand the data characteristics and also the quality. You also might have to use tools to load from CSV file, to load data from CSV files into the tables Examples are nothing but loaders. In Oracle, we have SQL loader. Using SQL loader, you can load CSV files into the tables directly, right? So you have to be familiar about those tools. The reason why I'm getting into these level details is because when it comes to conventional data warehousing, if you use tools like Informatica, or for data warehouse, if you use Teradata, or Oracle Exadata, etc., even though you don't work on these things on regular basis, or even though you do not highlight these as skills as part of your profile, you have to work on these things. You have to be familiar about SQL loader, export data pump, import data pump if you are from Oracle background. And you need to make sure you understand that those similar responsibilities will be there even in the data engineering world. And you just have to use different tools which are generic in nature. Instead of using a specific tool which is relevant to a specific data warehouse or database, which is proprietary to the database, you have to use generic tools and frameworks. So the responsibilities doesn't change, but the approach will change. Instead of narrowing down to one database technology, you have to come up with the solutions that are generic in nature. That's why I'm getting into all these details. So on top of building ETL pipelines using Informatica, Abinitio, data stage, etc., you also need to make sure you understand how to export, import data, how to load data from CSV files into database tables, and also how to run ad hoc queries on top of tables to understand the data, which means you should be very strong in SQL, right? And these are the skills which are required to be data engineer also. But it's not as simple as that. You need to be a bit comfortable with programming. Python is the programming language. If you're comfortable with the PL SQL, or even developing the workflows using Informatica and all, you should be able to pick up Python if you learn in a structured manner. Okay. On top of these things, you also need to understand how to deploy and schedule workflows using tools such as Control-M, AppWorks, etc. Tools like Informatica is typically used for the ETL development, but outside of it, you want to schedule on a regular basis. You want to make sure the operations team is notified if something is failed when the ETL workflow is have run, or ETL mapping have run. For that purpose, you need to make sure it is when I say it, I'm talking about the ETL mappings are integrated with external workflow tools such as Control-M, AppWorks. So you need to be familiar about those also as a seasoned ETL developer. So these are the key tasks which you perform, and the key responsibilities are primarily to get data from source into the tables, into the data warehouse tables. Now, what are the limitations of this approach? I'm not talking from the ETL developer perspective. I'm talking about the conventional data warehousing. What are the limitations of conventional data warehousing? There are not responsibilities or limitations of a ETL developer or data warehouse developer. When it comes to limitations, the first one is underused infrastructure. Many times you will plan for the database or ETL tool capacity to cater your peak demand. Okay, and your peak demand will be only a few hours per day or few days in a year. If you think about a retail company in US, the peak days will be around Thanksgiving, and for the rest of the days there will be peak hours, but consistently it will not be the same, right? And especially with respect to ETL process, the ETL jobs will run only nights, so that the reports are provided to the business users by the time they log in into their systems in the morning, right? So for that, from that perspective, or for that reason, typically the ETL jobs run in the night. And for your night demand, you have to plan for your data warehouse capacity and also your ETL tool capacity, which is not right. For the rest of the time, the infrastructure will be underused. High maintenance costs, there will be significant amount of maintenance costs. Restrictions to scale, you will not be able to scale up as much as you want. Designed to designed to deal with only structured data. If the data is unstructured or semi-structured, there are quite a few challenges, even though they have overcome significantly now, but still there are few challenges with respect to dealing with semi-structured data. Limitations related to metadata development. Probably now they might have fixed up to an extent, but still I see there are certain limitations related to metadata driven development, especially to ingest data into data warehouses or data lakes. So this is the list of the limitations with respect to conventional data warehousing. Now, data engineering solve most of these problems. The most important problem is the first. The most important problems are the first three. The last two are not that significant, but the first three are most significant. Underused infrastructure, high maintenance costs, and restrictions to scale. Data engineering on cloud solve these problems in a robust and reliable way. You will understand by the end of today, by the end of the workshop, which is nothing but tomorrow. Now, what is data engineering? Data engineering is nothing but conventional data warehousing only from the conceptual perspective, not from the implementation perspective. The implementation have changed significantly. On top of it, we also need to think about modern analytics. I will give an example or use case, and I will walk you through the details about what is this modern analytics very soon. It is becoming more cloud-oriented, which will reduce the infrastructure and maintenance costs with unlimited scalability. When it comes to data engineering on cloud platforms, these are the major ones. Data engineering using AWS Data Analytics, data engineering using GCP, data engineering using Azure, data engineering using Databricks, data engineering using Snowflake, data engineering using CDP. CDP is nothing but Cloudera. Hortonworks, Mapper, and all are dead. If you still focused on Hortonworks or Mapper, it is time for you to come out of it and focus on these areas. I would prefer to use any of these six: AWS, GCP, Azure, Databricks, Snowflake, CDP. Again, Databricks, Snowflake, and CDP runs on AWS or GCP or Azure only, and hence it is very, very important for you to pick up one of these cloud platforms, either AWS or GCP or Azure. Out of these three, from the enterprise world, AWS and Azure are more popular. So make sure you focus on either AWS or Azure to begin with. So these are the different cloud platforms which you should focus on. Now, this is how the architecture of a data engineering on cloud will look like, or data lake on cloud will look like. You will have an underlying cloud platform at the bottom. Then you will have a distributed runtime. Even distributed runtime will be on top of the cloud platform only. Actually, this is cloud storage. I have to fix this diagram. I will update the deck after today's session. So the storage and the runtime are decoupled. On top of it, you can build the applications you want to build, whether it is data engineering, which is nothing but our ETL pipelines, whether it is BI reports or dashboards, whether it is data science and machine learning modules, or real-time data applications. These are the things which you typically do once the data lake is built with appropriate architecture. Now, let me give a simple example to make sure you understand what these actually mean. Okay, for that I'll be using LinkedIn. Let me go to the linkedin.com. Okay, so if you look at this, once we have data lake built, on top of it, we need to build ETL pipelines. We need to build reports and dashboards, or the organization need to use the data in this data lake for reports and dashboards of that organization. We need to implement data science and machine learning modules, and also we need to have some real-time applications. Now, this is my profile. Sorry, this is my feed, not the profile. And if you look at this, first let me start with data engineering solutions. Okay, data engineering is general. I'll come to the data engineering at the end. First, let me talk about the BI and analytics, and then real-time data applications. Then I will talk about data science and machine learning algorithms, data science and machine learning based applications. Then finally, I'll talk about what is data engineering in this for the platform like LinkedIn. Okay. Now, this is my LinkedIn feed. First, when it comes to the BI and analytics, which are nothing but reports and dashboards, these are predominantly for executives of the organization. LinkedIn might have quite a few executives like CEO, CTO, COO. Underneath them, they might have VPs or SVPs or directors, whatever the terms they use for their hierarchy, right? Typically they use the term VP, who actually own a particular business unit. So the VP and his business team, want to see reports and dashboards about how their specific unit is performing. Now let's take the example of paid customers of LinkedIn. Okay, I think now I have stopped my paid subscription. Earlier I used to be a paid subscriber. When someone subscribe as a paid customer for LinkedIn, it is a transaction between that paid subscriber and LinkedIn. And the executive who is actually managing the subscriptions of LinkedIn, of general users like us, might want to see how his department is performing, whether the subscriptions are growing on regular basis, whether there is any attrition with respect to the subscriptions. Like that, he wanted to see reports and dashboards. So those are typically served using tools like Tableau, ClickView, etc., where the executive can play with the report and dashboard and understand where he should focus on and then take it further. Okay, so that is an example for business intelligence and analytics. Another example is LinkedIn is also a paid platform for recruiters. There might be hundreds and thousands of recruiters, or even millions of recruiters who might be using LinkedIn. Might not be millions, at least few lakhs. In US, we call them as hundreds of thousands. So there might be hundreds of thousands of recruiters who might be using LinkedIn. They will be paying on monthly basis. And now the top management who is actually driving that recruitment business might want to see how their subscriptions are performing, and they might want to see some standard reports and dashboards, and also they might want to play with to understand where they should put effort on to increase the revenue for that division, right? So these two are the examples for business intelligence and analytics. Now, what are real-time data applications? There are quite a few examples when it comes to real-time data applications. Now, if I search for, let me go to the jobs here. Okay. Now I'm going into the jobs page, and you see there are quite a few things here. My jobs, job alerts, salary, skill assessment, etc. And once you start searching for the jobs, it will actually show you the relevant jobs for you based upon certain machine learning algorithms. So it actually covers both the aspects, data science and machine learning algorithms, as well as real-time data applications. I should be able to search for jobs in real time. Typically, this data will not be stored in traditional RDBMS databases. They'll be stored in NoSQL databases. Once we start applying for the jobs, there should be recommendations that should come based upon our earlier search patterns, right? Even though once you start searching in the platform, it might not involve too much of data engineering. The data might be coming in from a NoSQL database, but under the hood, to actually get you the recommendations, they have to calculate affinity based upon certain keywords, and they have to build that index where, based upon your profile, what are the recommended job titles, and then from those recommended job titles, it can go and search for relevant jobs and give you the details. So this process of building your recommended jobs is based on machine learning algorithms. So jobs is both real-time data application for customers like us, and also there is a lot of machine learning machine learning and data science going on under the hood. Okay. Now, then comes data engineering. When it comes to data engineering, if I take the first example of getting reports and dashboards related to performance of recruitment division in LinkedIn, and also paid subscriptions of regular customers like us who are nothing but IT professionals. So there they have to get data from traditional databases, store it into a data lake, process it, and then port the data into dimensions and facts so that the executives can see the reports and dashboards. That is one way of getting the reports and dashboards for the enterprise executives. Okay. On top of it, based upon the search patterns, it might have to apply certain machine learning algorithms on top of that data which is relevant to particular user, or even in general also based upon the keyword based on which people are searching for the jobs. And then it has to build the recommendation engine under the hood using certain machine learning and data science algorithms. So data engineers are the ones who will take care of getting these data from the sources into the data lake, then processing the data lake, and port the data back into either traditional data warehouses such as Teradata or Redshift or Snowflake, whatever it is, or into NoSQL database, so that the pages like this one work without any issues. If you understand the characteristics of the business intelligence and analytics and real-time data applications, even both of them will be exposed to the end users. But when it comes to BI and analytics, the users are typically executives of the organization. The number of the users will be very small. It will not be very huge. And as the number of users are small, one more characteristic is the complexity of reports and dashboards will be significant. You need to build quite a lot of complex reports and dashboards. Number of users are small, but complexity is high. And we use traditional BI tools to serve these reports and dashboards to the executives, because the traditional BI tools provide authentication, authorization, and many other things out of the box, ability to send the report or dashboard in well formatted PDF or Word document as an email. So these are the features which are provided to you by traditional BI tools. As there will be only handful of executives, they go with traditional BI tools to serve these reports and dashboards, which come under business intelligence and analytics. When it comes to real-time data applications, if you try to understand the characteristics of real-time data applications, now if you take the example of jobs, there will be hundreds and thousands of users who might be searching concurrently in LinkedIn. And for all of them, the search results should come up. And if you look at the feed, even though there is a lot going on under the hood, it's a very simple feed. You don't have much of flexibility. So the complexity of the report is not that high. It will not give too much of flexibility for the end user, but the scalability is the challenge here. If you just try to give subscriptions of Tableau, ClickView, or any other BI tool, it doesn't work because the number of users are too big, and the cost will be significantly high for the vendor and also the end customer. When I say vendor, in this case, it is nothing but LinkedIn, and also end customer for us, it will be quite expensive, and also performance-wise, also it is not great. You will not be getting sub-second performance using the traditional BI tools. It will be in few seconds, which is acceptable for executives to understand their business. But when it comes to jobs, or I'm also YouTube content creator, I might want to see my reports. Even if you take the example of LinkedIn, the recruiters might want to see certain reports and dashboards. Let me give another example so that you understand more about it. I also have the ITversity company page. So if I go to my company page, should be able to see some statistics. You see, these are all nothing but statistics. Now, if LinkedIn actually provide this dashboard using Tableau or ClickView or similar technology, then it is very costly affair for them. If it is costly for them, it will be costlier to the end customer like us, and hence they don't actually provide reports in this these kind of reports using tools like ClickView, Tableau, etc. Rather, they build web applications. So the example for real-time data applications is nothing but reports like this for all the company pages. Okay. For this also, data engineers have to get the data from different sources into the data lake. Once the data is in the data lake, they have to aggregate and put the data into the NoSQL database, or sometimes we might even use RDBMS database. And then from there, the reports will be served to the customers. Okay, so that is the relevance of this important image. However, the storage is not right at the bottom. It should not be cloud platform. It should be cloud storage. I will definitely change it. So far, if you like the content which is covered, make sure you hit the like button. And also, if you haven't subscribed to our channel, just a gentle reminder, subscribe to our channel and also click on the notification icon. You will be notified whenever we conduct these kind of workshops in future. Okay, there seems to be few questions. Yeah, let me actually take few questions here. I wanted to take towards the end, but someone raised the hand. Yeah, in case of any questions, whoever are joining through Zoom in this webinar, make sure you post your questions in the chat. I'll come to the questions. Someone raised the hand, that's why I'm highlighting this. I'll take all the questions towards the end of today's session. Now, when it comes to different types of applications in a data lake, you will have upstream applications as well as downstream applications. Upstream applications are nothing but, if you take the LinkedIn as an example, the upstream application for data lake of LinkedIn is nothing but the portal where you end up paying subscriptions for your usage, or you might want to sign up for LinkedIn and update your profile. These are all upstream applications. And also, even searching for the jobs is kind of an upstream application, and also it can be downstream application also. So you might have to get the data from this jobs portal in LinkedIn, process it, and then push the data back again into the same one. And typically we use data lake in the middle with distributed computing capability to build certain indexes in the actual jobs application or job style applications of platforms like LinkedIn. So those are the examples for upstream applications. I thought there's a slide for it, but I think I forgot. I will add it. And then comes the downstream applications. As I mentioned to you earlier, executive reports and dashboards, customer analytics, recommendation engines. Jobs is nothing but recommendation engine. On top of it, you also have data science or machine learning applications, integration with external applications via REST APIs, publishing data to external vendors or customers. I'll cover these details very soon, the last two. For now, we have covered the rest of the details. Now, when it comes to typical data pipelines, we build as part of the data lake. One of the popular architecture is nothing but Lambda architecture. Using that, I picked the image. More than Lambda architecture, I wanted to emphasize about data sources and then getting the data into the target systems, either in batch or real time. At a higher level, you typically build these pipelines as a data engineer, streaming pipelines or batch pipelines. Mostly, you will be working on both. Means I can say 50-50 or 55-45. It all depends upon the nature of the portal. Okay, if it is LinkedIn, you will have as much data as you have to process in a streaming fashion, and also in batch. In some cases, batch might win. For example, if it is an enterprise customer, or if it is a small e-commerce portal where there is not much data that is being generated on regular basis. If the requirements are not too much catering around streaming kind of use cases, if the requirements are primarily to see reports and dashboards which are related to conventional data warehousing, even though the requirements of a small customer is similar to conventional data warehousing, such as providing reports and dashboards on regular basis, still we have to consider this modern approach to implement solution for him. The cost will be significantly lower for that customer. So keeping all these in mind, if it is a small customer, for some customers It might be batch pipelines only. For some customers, it might be streaming pipelines only. It all depends upon the category of the organization and the way they are building the reports and dashboards. So it is mostly 50-50 streaming pipelines and batch pipelines. As a data engineer, you primarily work on this. As part of the conventional data warehousing, even though the real-time replication CDC are there, but it is not as popular as building the regular batch pipelines. But with a modern data lake approach, you have to consider streaming pipelines as seriously as batch pipelines. This is a very important diagram which you need to keep in mind. When it comes to the target here, you need to visualize in such a way that both can be kind of multiple technologies that are supposed to be used in an organization. Okay. For example, sometimes even for real-time processing, you might end up storing data in conventional data warehouse type of tools such as Redshift. Even though data might be flowing in real time, the report characteristic might be batch. Okay, so data comes into the data lake in real time, but there will be batch job which will be populating these tables. At the same time, in the streaming fashion, you might also have to populate NoSQL databases. Even in the batch processing also, sometimes you might have to load the data into a data warehouse. At other times, you have to load data into the NoSQL databases for serving real-time data applications, such as jobs portal of LinkedIn. Okay, so when it comes to these are category of databases which are supposed to be used depending upon the nature of the applications that are issuing queries against these databases, and we need to provide responses depending upon the requirement. Now, here are two categories of data pipelines. This I have already covered in detail. Now comes the different platforms I have already highlighted in the past. Now I am giving a visual representation of it. AWS, GCP, Azure are the three prominent cloud platforms from the perspective of data engineering. Probably Oracle also might play a bit of a role very soon, because Oracle have a very strong presence in enterprise world with Oracle as a database. They might end up innovating something around this, and there might be some offerings around Oracle Cloud also. IBM also will be might be one of the contender in this, because IBM acquired Red Hat recently, and they have OpenShift, which is kind of a private cloud, and they might come up with some private cloud based solutions as well. So you can keep an eye on IBM and Oracle. But as of today, these three are the prominent cloud platforms on which data engineering is being done. When it comes to solutioning, either you can take the route of native or agnostic. So if you want to use AWS as a cloud platform, and if the client wanted to build the solutions using AWS native services, then you have to be familiar about all these tools. DMS for data ingestion from traditional RDBMS tables into the data lake, then Redshift for the data warehouse, DynamoDB for NoSQL database to serve your real-time data applications, EMR or Glue primarily for large-scale data processing. Kinesis is primarily for streaming data ingestion. Again, the data from the Kinesis will be processed by either Lambda functions or EMR, depending upon the characteristics of the data. So these are some of the technologies which are relevant when it comes to coming up with a solution using AWS native. Like that, we also have quite a few things in Azure. You can use the ADF for pipeline orchestration. In AWS, we have something called as step functions. In Azure, we have ADF. Then we have Azure Kafka. We have Cosmos, which is the NoSQL database. We have Synapse, which is nothing but Azure-based data warehouse. So these are the key skills if you wanted to, or if your client wanted to build Azure, build the data lake and solutions around data lake using Azure native approach. However, now the trend in the enterprise world is to be cloud agnostic. In case if the client wanted to go with a cloud agnostic approach, then you can consider either Snowflake or Databricks or Cloudera. Keep in mind that even though your client want to be cloud agnostic, taking the route of completely cloud agnostic without dependency on the underlying cloud platform is a very costly affair. In most of the cases where the enterprises don't want to go with cloud native approach, it will be a hybrid approach. You have to use some of the existing cloud features, and also you have to use cloud agnostic platforms like Databricks, Snowflake, Cloudera, etc. So mostly it is either cloud native or it is hybrid. Going 100% cloud agnostic is not a viable solution for the enterprises. Keep this in mind if you are at an architect level, so that you come up with a proper plan for your client. Now, this is the general reference architecture, again, based on the Lambda architecture, where we have both streaming as well as batch pipelines. We'll have different types of sources from which data is supposed to be. Let me see if I will be able to zoom in. I'm not able to zoom in. Let me see if I will be able to zoom in now. No, zoom in is not working. Let me open the original diagram. Okay. If you are watching live, make sure to subscribe and also hit on notification icon if you want to get notified. Also, if you are watching the pre-recorded video, don't forget to subscribe and click on notification icon so that you will be notified whenever we conduct these live sessions. And we'll be conducting quite a lot. If you want to be part of our newsletter, as part of the description of the video, there's a link. You can click on it and you can sign up for our newsletter. Now, yeah, this is better, I guess. Let me explain. So this is again based on Lambda architecture. So we'll have purpose-built databases from which data will be sourced. Once again, if I take the example of LinkedIn, the transactional data about subscriptions of recruiters and IT professionals like us might be in Oracle database. The jobs page might be on DocumentDB. The search, even in the jobs page, you have the ability to search, right? So for search also, there might be some search-based database. So there's a concept of purpose-built databases in microservices architecture using polyglot and all. These days, most of the applications for enterprises are being built using different database technologies, and all these database technologies can be sourced to your data lake. On top of databases, you also might get data from the web server logs, which might end up logging certain key information about the IP address from which the particular request is coming and all. So this will help the enterprises to address DDoS attacks and also spam, etc. Okay, so there will be a lot of log messages that will be provided to you on top of the data from these purpose-built databases. So from these purpose-built databases and the log sources, or even REST API-based sources, when you try to integrate your data lake with third-party companies, you have to get this data into the data lake. So when it comes to data lake, we implement using multi-layered architecture. So we'll have bronze layer. Bronze layer is like ODS, where you will be having tables similar to your source data. From there, you will have enriched data, and finally presentable data in the gold layer. Once you have data in the gold layer, either you can connect your reporting tool directly to this, or you can port the data from this gold layer in the data lake into the data warehouse or NoSQL or RDBMS, and you can serve the reports and dashboards using appropriate tools or applications. Okay, so this is the general reference architecture. In the middle, you have the distributed computing framework, which is nothing but Spark. You can leverage it to process large-scale data if it is relevant. Keep in mind that this distributed computing framework, especially Spark, is only 15 to 20% in your overall solutioning. Spark will not be 100%. Okay, there are quite a few other things which you should be aware of, and you have to build solution depending upon the requirement. You will understand what I'm talking about by the end of the workshop, why you don't need to use Spark all the time. Spark is only a framework. Don't give too much of weightage to Spark. The way Hadoop have dead, Spark will not die. Spark will stay for a very long time. But Spark will be one of the key skill with respect to the data engineering. It will not even be there as part of the JDs in future. Similar to Pandas as of today, they will just ask about your cloud capabilities, SQL capabilities, and probably your programming abilities and integration abilities down the line. Okay, from that perspective, Spark also will lose its prime. It will become a very essential skill, not the niche skill down the line. As of now, it's niche, but in a year or two, it will become an essential skill. And you can build some of the solutions using Spark depending upon the use case. You will not be able to, or you will not be using Spark in solutioning the complete thing. You have to focus on the other areas to build the solution. If Spark is relevant for a given use case, you will use Spark. Okay. So that being said, on top of data warehouse, NoSQL or RDBMS, which serve BA tools and web or mobile applications respectively, we'll also have data science and machine learning algorithms running on top of our data in the data lake. Also, many times we might have to provide the data in the form of CSV or JSON files to the external customers. We might have to integrate into their Kafka cluster or data lake directly if they expose certain APIs. So you might have to build solutions to push data out outside from the data lake to the external customers. The reason why they use the term lake in data lake is because if you think about a real lake, you will be having water coming in from multiple sources. It can be upstream rivers from where the data might, the water might be coming into the data lake. It can be sewage from a factory. Like that, there can be a number of sources which will get you data into the data lake. And depending upon the characteristics of the water that is coming into the data lake, you have to make sure the solution is there to get water into the data lake. Water into the lake. I'm mixing up the real lake and data lake. But the intention is, let's stick to lake and water. Okay. If it is a regular lake, there will be multiple sources from which water will be coming into the lake. Depending upon the characteristics of the water, you have to make sure certain processing is done before the water is ingested into the lake. Now there will be downstream users for this water, right? It can be households, it can be factories, it can be farmers. There will be a number of different type of downstream users of this water. Similar to lake, even data lake will have upstream data sources and downstream applications. And depending upon the characteristics of those data sources and the downstream data sinks, you need to come up with the solution. And you have to have this high level overview as a data engineer to be productive and effective as part of your projects related to data lake and solutions around the data lake. Now, let me give few examples about where you will be. You need to work on providing the data in the form of CSV or JSON files. Again, I am actually going to LinkedIn.com. Okay, because of the compliance reasons, each and every social platforms like this, they have to make sure that they provide the data to the customers like us whenever we demand. So in this case, I can go to me. And I can go to settings and privacy. As part of settings and privacy, there is the data privacy. Get a copy of your data. Okay, you can choose whatever data you wanted to get from LinkedIn. This is not for the compliance purpose. This is the feature provided by the LinkedIn. But in many cases, for compliance reasons, also you might have to provide certain data to the users who are requesting it. Okay. Now you should be able to select whatever you want and you should be able to download. You will not get the data immediately. There will be a request placed in the pipe, and when your turn comes, they will generate the data and give it to you. It might take few minutes. Earlier, it used to take a little bit more time, but now it will take just a few minutes. But it is not immediate. It is asynchronous process. Once the data is generated, then you will get an email notification. Then you have to come here and download the data. This is one use case where you might have to get the data from your data lake and provide the data in the form of CSV or JSON files to the end users. Also, if I'm a recruiter, if I'm an enterprise recruiter, I might want to see a performance of my job postings and all. And I might want to get some data on regular basis from LinkedIn so that I can port the data into my portal or into my data lake, and I can do some analysis based on the data. So there are quite a few use cases like that where the platforms like LinkedIn, Amazon, etc., end up providing data of their customers on regular basis. For example, if you are a vendor on LinkedIn, sorry, not LinkedIn, but Amazon, if you sell products and if you sell products on Amazon as a vendor, you might want to see how your products are performing. So Amazon will actually provide a data feed for you based on the SLAs between you and the Amazon, and you should be able to consume the data, port it into data lake, and perform data analysis on top of it. Okay, so that's where getting the data in the form of CSV or JSON. Sometimes we might even end up integrating data directly into their Kafka cluster or data lake by using certain APIs. So this is the general reference architecture when it comes to coming up with enterprise solutions around data lake. Now let's go to the next slide. Let me go to the slideshow. Yeah, next slide is primarily about how to solution using AWS. So I have AWS reference architecture diagram also, you can see here. Picking the general reference architecture, I have come up with AWS based architecture where we have S3 at the bottom, which is nothing but AWS storage. Then we have AWS EMR or Glue, which is nothing but a distributed computing framework. And then for the ad hoc analysis, either you can use Amazon Athena or Redshift. Redshift also had a feature called as Redshift Spectrum, where you can create a table or use existing tables in Glue catalog. The table will be exposed in Redshift. Once the table is exposed in Redshift, without having any distributed computing engine in the middle, leveraging the Redshift infrastructure, you should be able to query the you should be able to run the queries on top of S3. I'll be demonstrating tomorrow. You will understand what I'm talking about here. That's why I'm saying the relevance of Spark will go down significantly in future. You don't need to even if you use it, will be abstracted from you in the form of SQL. The SQL is the most important skill when it comes to data engineering. Okay, so coming back to the architecture diagram from the perspective of AWS, you can use Amazon Redshift for both ad hoc analysis as well as reporting. Athena also can be used. Both Athena and Redshift can be used, but Redshift is more popular as per my knowledge goes. Because Redshift also have these features such as Redshift Spectrum and all. Probably Athena might lose its prime very soon, but I'm not 100% sure about it. You have DynamoDB for NoSQL, so you can actually port your data into DynamoDB if you wanted to use AWS native approach to build your web or mobile applications for your real-time data applications. For machine learning and data science, we have AWS SageMaker. We have to build the solutions for these use cases. When it comes to ingesting data from purpose-built databases into the data lake, when it comes to AWS, you might end up using DMS. DMS is nothing but database migration service or data migration service. I do not remember 100% on top of my head. MS for migration service, D for either data or database. So you can get data from source databases into data lake by using tools like DMS. Okay. On top of it, yeah, I already mentioned EMR or Glue to actually process large-scale data using Spark engine. If you wanted to ingest data in real time, you can use either Kinesis or MSK. MSK stands for Managed Streaming for Apache Kafka. So either you can use Kinesis or MSK. They also propose the design where Kafka and Kinesis can be integrated. I will also explain as part of the course, if you sign up for our course, about when Kafka plus Kinesis might be relevant. But for now, I don't want to get into too many details. Keep in mind that for real-time streaming, you can use Amazon Kinesis or MSK. To get data into the data lake again, it need not be structured streaming of Spark. It can be, there are multiple ways to solution around it. This is the reference architecture with respect to AWS. Even Azure also more or less will be the same. You just need to make sure you replace the service names depending upon the services we have in Azure. Databricks is a cloud agnostic example. And if you wanted to build a solution using Databricks, then this is how it will be. Called as DBFS, which is abstraction on top of underlying cloud storage. It can be on top of S3 if it is AWS, or Azure Blob or ADLS if it is Azure. It can be Google Cloud Storage if it is GCP, because Databricks is available on all the three platforms. Okay, and then once you have the data in the data lake, then you should be able to use the Databricks distributed computing engine, which is based on Spark, to process the data. And you should be able to use Databricks SQL to run reports and dashboards directly off of the data which is in data lake. You don't need to move the data anywhere. You can directly run reports and dashboards using Databricks SQL. On top of it, another common pattern with respect to Databricks is we use the Databricks connectors to push data to underlying cloud data warehouse or target cloud data warehouse. It can be AWS Redshift if it is Amazon Redshift if it is AWS. It can be Azure Synapse if it is Azure. It can be BigQuery in GCP, or it can be Snowflake also. One of the common pattern is people use Databricks for distributed computing, and they use Snowflake to build the data warehouse. So here, Snowflake and Databricks are actually competing to capture that cloud agnostic market. If you look at the offerings, they are more or less the same. But still, there might be some scenarios where enterprise might decide Snowflake as a enterprise data warehouse. For distributed computing engine, they might end up using Databricks. Okay, but it will not be other way around. They will not use Snowflake for the distributed computing and Databricks SQL for the data warehouse. That will not be the case. But in many cases, there is a possibility that Databricks is used as a distributed computing framework. But when it comes to reports and dashboards, they will be built on top of Snowflake. Using Databricks and Snowflake connector, you should be able to push data into the data marts in Snowflake, or dimensions and facts in Snowflake, from which reports and dashboards can be built. This is the architecture diagram from the Databricks perspective. Now, let me systems. Yeah, I think I got mixed up. Yeah, so these are the systems that are relevant for the data engineering. Variety of source or upstream systems, purpose-built databases, files, REST APIs. Then data lake, we have downstream systems such as data warehouses or MPP, NoSQL, external systems, etc. Okay. Now, what are the skills to be a data engineer? You need to have extensive knowledge of SQL. You have to be a really advanced SQL user or SQL developer. When I say SQL developer, I'm not talking about PL SQL, just plain SQL. You should know how to create tables, how to get data into the tables. That will come handy when you want to perform unit testing and all. On top of these things, you also need to familiar about how to create external tables depending upon the files in S3. Also, from the writing SQL queries perspective, you should be familiar about basic SQL, the joins, the advanced SQL such as ranking, etc. On top of it, you also should be familiar about data modeling. These are the skills which you should be familiar about when it comes to SQL. Mostly ETL developers should be familiar about it. Seasoned ETL developers should be familiar about all these areas. But one area where they might be lagging at this juncture can be processing semi-structured data. Already there are functions and all available in all data warehouse technologies, even traditional RDBMSs such as Postgres. When I talk about data warehouse technology, Snowflake, Databricks SQL, Redshift, all of these technologies have ability to process JSON data as well using appropriate function or appropriate functions. You should be familiar about how to use appropriate functions to process semi-structured data. I'll be giving a demonstration tomorrow on that, and you'll be fairly comfortable with it. So on top of traditional SQL skills, you also need to be comfortable with respect to processing JSON. Also, you should be proficient with performance tuning techniques as you gain more and more experience. How to partition the data? What is the criteria to partition the data? Whether data should be in a data lake, or whether we need to have a copy of the data in the data warehouse layer. if you use technologies like Redshift, which support both querying on top of data lake directly. You can also copy the data into Redshift and run queries on top of it. So you really need to understand some of the key internals to make sound decisions when it comes to building solutions around your data lake. Okay, so extensive knowledge of SQL is the key for your success as a data engineer. Then programming abilities, you should have programming abilities, but the industry is going towards low code or no code. Okay, but it doesn't mean that you should have Python skills or you can avoid programming skills. Python is the programming language to go when it comes to data engineering. There is no competitor for it. No one is close to it. Remotely, Java will be there because most of the developers as of today are still Java oriented. But eventually, even those are forced to transition into low code or no code approach, where you will be plugging in some of the solutions using Python as a programming language. Whatever is built using Java, that will stay like that until they break it down and re-engineer, like the way mainframes survived for quite a long time. But eventually, everything will be Python driven when it comes to any programming with respect to data engineering. So programming abilities, preferably Python, but you will not be using as frequently as SQL because the industry is going towards low code or no code. But keep in mind that you should be very comfortable with Python. And also you should be very comfortable with all the modules that are available out there. Depending upon the requirement, you should be able to quickly stitch and come up with the solution without writing too much of code. Okay. Then comes the data processing frameworks. You should have decent knowledge about Pandas and Spark. Then key data engineering or data lake or data warehouse services on the cloud. If it is AWS, S3, Glue, Catalog, EMR, Redshift, step functions for orchestration. If it is Azure, ADLS or Blob, Azure Databricks, Synapse, ADF. If it is GCP, GCS, Dataproc, BigQuery, Airflow, etc. Airflow is the agnostic orchestration tool. If you know Airflow, you can even build pipelines on AWS or Azure as well, but GCP doesn't have any cloud native orchestration tool or GCP native orchestration tool. It promotes Airflow itself. You should be in a position to build orchestrated pipelines, which include scheduling also. So the knowledge of your controller, mapworks, etc., might come handy to pick these skills quite fast. Okay, if you think about it, all these are nothing but different tools which will facilitate you to perform the traditional responsibilities only. Once again, I'm reiterating. When it comes to data warehousing, the traditional responsibilities are nothing but not only building the workflows, or not only building the mappings, but also ability to export the data and import the data, load the data using tools like SQL Loader from CSV into the tables, run queries to understand the data, right? Performance tuning is also there. You should be familiar about performance tuning to make sure the performance is at its best. On top of all these things, you also need to be familiar about workflow and orchestration. And here, these are all nothing but cloud-based services for the similar stuff. Okay, if you conceptually clear about all those tasks which you tend to perform in legacy data warehouses, you should be able to map those to these modern data lake or data engineering solutions, and you should be able to pick quite fast. Okay, if you are a seasoned ETL developer or PL SQL developer or even a mainframes developer, where your primary responsibility is to get data from mainframes and provide to the external world, then you are already 50 to 60% there. Only thing is, you need to spend some time and understand the modern approach and gain some knowledge with respect to Python, and you should be good to go. Okay. That being said, I will answer quite a few questions around this towards the end of the workshop, which is tomorrow. Now, let's also look at the trends in big data and data engineering skills. Okay. Let me open in a slideshow. So the blue one is Hadoop. You see here, Hadoop is consistently going down starting from 2015. And recently there is a spike, but it will go down. Hadoop will die very soon. Okay, probably Recently, it is growing because of the transition going on from Hadoop to cloud. Okay. When it comes to Spark, it never became very top skill, but it will sustain at this level for quite some time. Okay. If you look at it, it never took off. Even though it is quite popular, it never took off like Hadoop. Hadoop became very popular at one point and then it slowly went down. Whereas Spark, it will just sustain at some level. Spark will be there in different forms, and you will be using Spark quite frequently as part of the projects. But it will never become a niche anymore. It will be one of the essential skills which you should be familiar about in building the data engineering solutions. Hive, which is nothing but yellow. Hive and Spark are nothing but SQL in the end. If you are familiar about SQL, you will be comfortable with the Spark, especially from SQL perspective. There is also way where you will be using Spark from the programming perspective also. But majority of the scenarios, you will be able to use Spark using SQL approach also. I will explain quite a lot of details with respect to Spark tomorrow. Data as a term also, it will slowly fade out. Big data you will not be hearing big data very frequently after a year or so. Data engineering is the one which will stay for a very long time. Okay, and that too, data engineering on cloud. Eventually, already it is in a mode where it is getting into serverless. But as engineer, you don't need to break your head around serverless. The platforms will provide you serverless features. You don't need to reinvent the wheel to again do some transition. Okay, using serverless, you should be able to build the solutions with the same knowledge what we have today. From engineering perspective, there won't be significant difference when it comes to serverless. When it comes to the skills, I'm comparing here between Databricks, Snowflake, Amazon Redshift, and Azure Synapse. You see, most of them are consistent because the technology landscape, the usage of this landscape is distributed depending upon the preference of the end client. But Databricks made its way out of all this competition, and it is a little bit up compared to others. Most likely, it will also sustain at some level. Okay, so here all these companies, Databricks, Snowflake, Amazon, Azure. When I say Amazon and Azure, I'm talking about only the data-related services. They created a healthy competition in the market for the customers to have right choice, and having as much knowledge on SQL and Python will help you to sustain as a data engineer. Okay, you don't need to be very fancy about Databricks or Snowflake or Redshift or Synapse. You just have to acquire these skills around Python and SQL, and you should be good to go. Okay. Now, skills to be a data engineer, we'll give quite a lot of demos. We'll start with simple Python demo where you will get the details very soon. But here is the agenda when it comes to covering what are the skills that are supposed to be known for a data engineer, especially using AWS Data Analytics. I'll give a quick overview about REST APIs and JSON with a demo, then data ingestion. It might not be demo, it will be an example. Then we'll also see how to perform ad hoc analysis using serverless SQL. We'll also talk about serverless orchestration. We'll also talk about ad hoc analysis of processed data. So this one is unprocessed data using Redshift. This one is processed data using Redshift again. Then we'll also talk about key integrations with the demo using AWS Step Functions and Lambda. We'll also talk about performance tuning with simple demo. I'll not be getting into too many details, but these are the things which will be covered as part of our guided programs. You will be learning all these things in an extensive manner. Okay, overall, you will be getting almost 200 hours of content, which covers Python, SQL, Spark, Kafka, and also all these key services such as Lambda functions in AWS, then EMR, then Redshift, then Kinesis and Kafka, then performance tuning. All these even step functions will be covered quite extensively. So you will be learning all these key skills as part of the guided program, and also the courses which we will be publishing in Udemy. Now, let's start with the problem statement. We'll start with this. we'll try to wrap up whatever wherever we stand in next 15-20 minutes. I will take some time for Q&A, and then we'll resume tomorrow. So the flow will be, first we will come up with a simple problem statement, then we'll come up with a design, then we'll actually get into the solutioning as well. Okay, so you will understand the overall process of how to build pipelines using a real world situation itself. So it is primarily based on running analytics on top of Salesforce leads or sales data using data lake and data engineering pipeline. I'll also give a brief overview about Salesforce if you're not familiar about Salesforce. We need to get data ingested from Salesforce into the bronze layer in the data lake. Data will be in semi-structured format. Then we need to apply required transformations and store the data in data warehouse. The data should be well structured and should be ready for reporting in data warehouse. So it's a very simple problem statement. It is primarily to touch all the services that are relevant to build pipelines like this. Okay. So this is the design using AWS native, and this is the design using Databricks. Rest of the things are same. Even with the Databricks, I am actually using AWS itself as the cloud platform under the hood. If it is AWS, the storage is S3, AWS S3. The data lake storage is nothing but AWS S3. However, if you look at this, if you are using AWS data analytics services, for large scale processing, you can use EMR. For reporting purpose, you can actually store the data in Redshift as a data warehouse. Whereas with the Databricks, again, you can use Databricks runtime to process the data, which is again Spark SQL. Whether it is EMR or Databricks, it is Spark SQL only. Then for reporting purpose, on top of this semi-structured data, one can use Databricks SQL and report, which means we should be able to build reports and dashboards using Databricks SQL. You don't need to move data to external world. But as I mentioned to you earlier, most of the enterprises might prefer a standard data warehouse if they are already using it. For example, if an organization have Redshift already in place, as long as Redshift also provide all these features, why they will move to Databricks SQL, right? For new organizations, probably they might consider Databricks SQL. If an organization on AWS already use Redshift or Snowflake, or if an organization on Microsoft already use Azure Synapse or Snowflake, then they might not move to Databricks SQL because already they are providing those features for you. Okay, so from that perspective, this is one of the possible design with the Databricks. This is the most viable design with AWS native services. So we will see how to get data from Salesforce ingested into S3. Then depending upon the characteristics of data, either we can pick AWS Lambda using Pandas and Spark SQL for distributed processing. The characteristic is nothing but the size of the data which you are supposed to process. If the data volume is not very big, then having a Spark engine to process small data set is not a viable solution. It's like hitting an ant with a stick, with a big stick. You don't need to use a very big stick to hit an ant or hit a mosquito, right? You have to use the appropriate tool to deal with that small insect. So if the data volume is small, you just have to use Python pandas to process the data. You can deploy it as a Lambda function and take it further. You don't need to use EMR, which will take care of some warm up, which will take some time to warm up before it provides the infrastructure, then deploy using Spark SQL, and then process it and do whatever you want downstream. It might not be a viable solution for smaller datasets. AWS Lambda can be a viable solution. Okay. As part of this workshop, especially the hands-on part, we will actually get an overview of Salesforce and AWS Airflow. Then we'll review CSV data with semi-structured or JSON fields. I will also get into a few details about how to interpret those files so that you are really comfortable. Then we'll upload files to bronze layer of data lake, simulating data ingestion from Salesforce via AWS Airflow. Then we will actually talk about how to process it using AWS Lambda, AWS EMR, using Spark SQL, so on and so forth. Okay, so let's get an overview of Salesforce. Salesforce is nothing but a popular sales and leads platform. It's a CRM, customer relationship management. If you know the history, if you are a veteran in the industry, at one point in time, CBEL is very popular. and Siebel is acquired by Oracle. It was a forceful acquisition, and the founders of Siebel came out of Siebel and they started Snowflake. That's what I have heard. I might be wrong. Okay, don't quote me if you are using the same story elsewhere. Okay, so Salesforce is I heard that Salesforce is invented by the same team, but it is predominantly based on cloud. Okay, it's a cloud platform where people can come and take care of their customers, especially from sales leads, enriching the leads, cross sell, upsell, to streamline complete sales process within an organization. And a lot of enterprises and also small companies use Salesforce. One of the prominent source to data lake, especially to understand our sales and leads data, is nothing but Salesforce. Okay, so Salesforce, you can actually go to salesforce.com and understand more about it. But as a data engineer, you don't need to be expert in Salesforce. Okay, you might have to learn a little bit about how to get data from Salesforce into data lake. There are multiple ways to get the data into the data lake. Either you can use REST APIs, which are provided by Salesforce, to get the data into the data lake. There are also SDKs or CDKs. SDK stands for Software Development Kit, which is nothing but a jar file or bundle which is provided to you, which you can leverage to use the functions that are provided by these vendors, such as Salesforce, and build solutions around it. Typically, these are nothing but wrappers on top of REST APIs. So either you use REST APIs or SDK or CDK, or third-party plugins to get data from popular technologies like Salesforce into data lake. And one of the approach which is typically used, especially in AWS, is nothing but Airflow. You get data from Salesforce using Airflow. I'll not be demonstrating Airflow related details at this juncture, because we also need to have Salesforce to really see that hands-on ingestion process. I'll not be getting into all those details, because having Salesforce account and then configuring Airflow and Salesforce will all take time. Okay, now let me actually go to aws.amazon.com. Let me log in. One of the service in AWS is nothing but the Airflow. Look at the details about it. It not only facilitates you to get data from Salesforce, you can also get data from Slack, ServiceNow. There are quite a few others. Airflow can also get data into those cloud platforms such as Slack, Salesforce, etc. It's not only getting data from sources like Salesforce. We can also use them as things using Airflow. Airflow is a fully managed AWS service, which will actually get you the data into the data lake. Okay. Now, once you use Airflow and configure what are the Salesforce objects from which you want to get data, and also the location to which you want to write in S3, it will take care of providing the data in the form of CSV, or it might support other file formats also. Okay. So the data which is generated by Airflow will look like this. I already have the data in S3. Let me open my terminal here. And to follow this very closely, you need to understand how the data is structured when data is ingested by Airflow into the data lake. Okay, the location in which I have uploaded the data is nothing but this one. Del CSV. Addresses.csv. Now let me get that file to the local file system. So I'm actually copying from S3 to local file system. You'll think if you sign up for our courses, you will understand how to configure CLI, how to get the data from AWS and all those things. folder called as downloads. Right. Now let me open that file. Several fields. ID is the first field. You can see ID, then first name, then last name, email, gender, IP address, phone numbers, and address. When it comes to ID, it is of type integer. When it comes to first name, it is of type string. When it comes to last name, it is also of type string. When it comes to email, it is also of type string. Even gender is of type string. IP address is also of type string. Even phone numbers is of type string. But if you observe, this is not a typical string. Okay. If you are familiar about programming languages, this is similar to a list. If it is Python, it is similar to Python list. Okay. If it is Java, it can be Java array, something like that. Okay. And again, if you look at this, even this look like a string, it is not a plain string. And if you see, there are double quotes here. I will explain what these are about actually. This is nothing but a JSON array. JSON array with 2 strings in it. And JSON arrays can be stored in the form of strings when we get the data into a CSV file. And the app flow will be writing the data into the CSV file. If there is a Python, if there is a list of Salesforce in the actual source data, it will be converted to a string using this format. If it is an object, or if it is a JSON object in a Salesforce data, then it will be represented like this. Okay. So this is nothing but a JSON which is represented in a string. When it comes to JSON, it is nothing but a key value pair. Let me actually go to JSON formatter here. What is JSON real quick, and then we'll take it further. So when it comes to JSON, it is like this. We are talking about address, right? So we have street. 1 is the value for street. City. Zip code. Zip can be number, like 1, 2, 3, 4, 5. Let me zoom in. So if you look at this, this is nothing but a JSON document. Okay. JSON document is nothing but a document which contains multiple elements. Each element is nothing but a key value pair. If you are from Java background, you can treat it as a hash map. If you are from Python background, it is similar to dict. Okay. If you are completely new to programming and if you are not familiar about hash map or dict, then you just understand that a JSON document is nothing but a group of key value pairs where keys are unique. So in this case, these keys should be unique. When it comes to these keys and values, this is known as value. When it comes to these keys and values, these can be of different types. These can be strings like this. These can be numeric values. So this is numeric value. Even the key can be numeric value. These can be Boolean values like true and false. These can be dates and timestamps also. So JSON support all those standard data types. Okay. Now strings in JSON are actually considered as double quotes. Okay. Now if I go back to the data, strings in JSON are typically represented in double quotes like this. Here we are trying to write a JSON document as a string to CSV because it is a CSV file, right? And all the strings, whether they are keys or values in the JSON, should be enclosed in double quotes. But this entire string is also enclosed in double quote, right? If you don't escape somehow, then this will be treated as one string. Then this will be treated. This might be treated as another string and all. It will cause issues. For that reason, if you have double quotes as part of your data, which is considered as one string, then we have a concept of escaping. You can escape using whatever character you want. In this case, the reason why we are saying double quotes is because we are using double quote itself as an escape character. In some cases, we might end up using backward slash as escape character. You might end up seeing something like this also when you represent as the strings in CSV files. If it is JSON, you might even represent like this. Instead of using double quotes as escape, you can use a backward slash as escape. You can use a question mark. You can specify what you wanted to use as escape character. Based upon the escape character, which is specified or which is used as default, you will see that escape character as part of your data in CSV. Now let me process it. You can see well-formed JSON here. It's a formatted JSON. So in this case, this is nothing but a JSON object. This is nothing but JSON array. As we have string values in this JSON array or JSON object, they are escaped using double quotes. That's why you are seeing double quotes here. Now, this is a semi-structured data. When it comes to phone numbers and address, this is semi-structured data. You should be able to use appropriate API in the underlying programming languages to process this. Okay. Even you can use SQL to actually process these semi-structured values in columns like phone numbers, addresses, etc. So this is what the data is about. Tomorrow we'll resume here, and then we'll talk about the rest of the things. For now, we have already reviewed CSV data with semi-structured or JSON fields, which are nothing but phone numbers and address. We'll also make sure the data is available in S3. Okay, already it is there. I have read the data from the S3 into the local file system, and then I have reviewed. The location of the files in S3 is nothing but this one. Using this location, we will see how to process using different approaches. Lambda, if the data volume is small, or Spark SQL, if the data volume is big. And we'll also go through the details about how to come up with solutions around this. That being said, now I'll take questions. Already there are quite a few people in online session. I will answer those questions. If there are any questions in YouTube, I don't see too many people in YouTube because I have informed in a last minute. In case if you have any questions, feel free to post the questions as part of the comments. Once you watch this pre-recorded live stream, I'll definitely be answering those questions in the comments so that your questions are answered. I'll also walk through the details about the course and all tomorrow after I complete the workshop. That being said, now let me take the questions which are asked in the live sessions. Hima have asked a question by saying, which says, if facts and dimensions are built using Spark or Databricks, what would happen in data warehouse like Snowflake, Redshift? So when it comes to facts and dimensions, we don't build using Spark or Databricks. Spark or Databricks will port the data into the facts and dimensions. Okay. Spark will not be used to create dimensions and facts at all. Okay. You will only use appropriate query or code to write data into the facts and dimensions which are created in the underlying data warehouse. The underlying data warehouse can be Snowflake, it can be Redshift, it can be Synapse, or it can be glue catalog tables on which you can actually run queries. So when it comes to fact and dimension, it's nothing but a metadata for a given data. There's no data at all. So you will create the tables and tables which are termed as facts and dimensions using whatever underlying data warehouse you have created. You will be using Spark or Databricks to get data into that data warehouse after processing, similar to Informatica or any other ETL tool. I hope I answered your question, Hima. If you have a follow-up question, you can ask it. Jamal is asking, should we concentrate on Spark skill? So Spark is not a skill, to be frank. It's just one small module similar to Pandas. Okay, you should give respect only up to that extent. It's a distributed computing engine. You can give a little bit of weightage for that. So if you go through our data engineering guided program on AWS, you will not have too much of emphasis on Spark. But if you take the essentials course, there will be a lot of emphasis on Python, SQL, and also Spark. But when it comes to data engineering using AWS Analytics, there will not be we'll be providing a good amount of material, but out of 200 hour content, it is only 20-30 hour content when it comes to Spark. There will be additional 10 to 15 hour content, it will be again on Spark SQL. Okay, so if you just focus on Spark, you will not go very long in the world of data engineering. It is one of the essential skill. It is similar to math in your high school. You will not get a job on math, right? You have to build something around it. Spark is something like that eventually. It will become something like that eventually. Okay, so Deepak is asking, what is the role of Scala programming language in today's big data universe? So it's better to get away from Scala and stick to Python. If you are an entry-level professional, it is okay because when it comes to job opportunities, they'll focus on your analytical abilities, your programming abilities and all. The world is going towards a polyglot where things can be developed using multiple programming languages, multiple frameworks, etc. If you are entry-level software engineer, probably based upon whatever programming language you are good with, they might hire you. But if you are a lateral, and if you wanted to get into data engineer role, it is better to focus more on Python. If you ask this question 2-3 years back, I would have said 50-50. Either you can choose Scala or Python. But now it's increasingly getting away from Scala completely, and it is more towards SQL and Python. Once again, even with Python also, you will not be coding too much. Okay, it is only as and when it is required. Question, Deepak. If you are a lateral, don't spend your time on Scala. It is waste of your time. We have asked 2 questions. Does AWS Data Engineering provide configuration like drag and drop when you say no or low code? Yes, there are solutions which will provide you drag and drop features. You will be coding using Spark SQL, means SQL or Spark SQL. Already there might be some existing tools like DBT. You might have to plug in the DBT, and you might have to write SQL queries and plug in. So something like that. Okay. When it comes to the core ETL logic, it will be typically be implemented using SQL. That's why I'm saying you should know SQL, but you don't need to code very extensively using Python. And for the orchestration and all, Airflow is not yet there when it comes to dragging and dropping and building the orchestration. But step functions in AWS, they came up with something called as Workflow Studio. Using that Workflow Studio, you should be able to build the orchestration quite fast. Azure ADF already have orchestration inbuilt. So tomorrow you will understand a little bit about step functions. Okay. Also, you have asked the question about guided program contents are same as Udemy course. Yes, more or less it will be the same. But in Udemy also, it will be covered in 8 to 9 courses. It is not just one course. You have to go through 8 to 9 courses to get the required knowledge of whatever is going to be covered as part of all these courses related to data engineering. Each course will be around 8 to 12 hours. Okay. So I will answer if you attend tomorrow's session, or if you watch tomorrow's workshop after the streaming is done. I'll answer this question in detail. What are the differences between Udemy and guided program? Who should sign up for guided program and who should sign up for Udemy? All those questions will be answered in tomorrow's session. So question, anonymous attendee. They're asking, one of your diagram you showed EMR, why not glue instead of EMR? You can also use glue. Glue also have something called as jobs and workflows, but glue is not completely open source Spark. It is a flavor of Spark which is native to AWS. Even if you go with AWS native services, it will be good idea to actually design and come up with the solutions using open source approach. Okay. If you write the code using glue, tomorrow if your client or your company, your employer want to migrate away from AWS into Databricks or into Azure, then all that code which is developed in glue has to be re-engineered and then retested. It will cost you dearly. Okay. So glue is also an alternative, but I don't recommend glue to our clients unless until they want to implement using glue. If they ask my opinion, I'll go with EMR because EMR is based upon open source Spark. If you build some solution using EMR, I don't need to worry too much about re-engineering the core solution. And that's why I emphasized on EMR than Glue. I might end up using Glue catalog tables here and there, but Glue jobs and workflows I don't prefer to use for the reason that it will lock in you into the AWS as a vendor, as a cloud platform. Question, Jamal. Being said, there are a few questions on YouTube also. Let me answer these questions. Venkata Narasimha is asking, if we think about next 15 years career, which cloud we need to consider, AWS, Azure, GCP, or Kubernetes on-prem? See, I always try to be familiar about at least two things. Even when I started when I started my career initially, even when I am working on Informatica, I was always curious about Abinitio when those are very popular. But once I start seeing Hadoop and big data coming into limelight, I felt those are irrelevant, and then I moved out. Okay, so I would highly recommend you to just explore two cloud platforms, and keep in mind that once you are comfortable with the one cloud platform, adapting to the other cloud platform will not be difficult. Okay. It is similar to SQL, but it is not as simple as SQL. When it comes to SQL, if you know SQL on Oracle, you should be able to run queries on Postgres or SQL Server or even Spark or even Databricks, right? SQL is a very standardized interface to interact with any database. When it comes to cloud, as it is deal with more at infrastructure level, the standardization doesn't happen at the same level as SQL. Okay, for that purpose, transitioning or learning additional cloud skills will be a bit hectic, but at the same time, you should be familiar about at least two platforms in your core area. If you are trying to be application developer, you need to know how to build applications on two cloud platforms at the least. If you are aiming to be a data engineer, how to build data engineering solutions on two cloud platforms at least. It will also make you better as a professional to come up with the solutions, because you will be hearing two perspectives also. So as you evolve, I would suggest you to at least go with the two cloud platforms. Asking a question, I'm from Informatica ETL background. Can I learn and move to data engineering field? Yes, Muhammad Ali. We will also have a group counseling session or one-on-one session to understand where you stand, and we will give you a roadmap about how you can get into data engineering role. If you are comfortable with SQL, you can be a data engineer within 6 to 9 months. There's no magic bullet. You will not be a data engineer by just going through 1 week content. It will not work that way. You have to be really focus on your fundamentals. The fundamentals to become data engineer on cloud are nothing but SQL, Python, and then cloud platform. Then you should be able to pick whatever skills you want as quickly as possible. For the first time, the first skill will take a little bit of time, but the second skill, which is similar in nature, you should be able to pick up quite fast. Okay. So Sai Adepu is asking, will M1 MacBook suffice to learn data engineering? Yeah, you can use any laptop. There is no restriction on your laptop. Okay, so don't worry too much about your laptop. Anything can be used, and you will not be setting up too much of stuff on your laptop. And if you sign up for our guided program, if you stuck in any issue, we'll be there to help you. Okay, even because of M1, I use M1 to create my content. I have not MacBook, but I have Mac Mini. I use this actually to record the content, and I use it quite extensively, and I don't see any issues with that. Okay, so don't worry too much if you have M1 or Windows. It doesn't matter as long as you have at least 8 GB laptop. You are good to go. But I would highly recommend to have a 16 GB laptop, because having 16 GB laptop will improve your overall productivity as an engineer. Okay, and Abhijit is asking how Docker Kubernetes is important in data engineering. Kubernetes will not be very important for data engineering. The reason is it's an infrastructure thing. There will be some solutions, wrappers on top of Kubernetes and all, which will be built. When it comes to Docker, you should be familiar about, depending upon what you are trying to do. For example, AWS Lambda functions also should be used quite extensively when it comes to data engineering. Not quite extensively, but in considerable number of use cases, you have to use AWS Lambda functions. If you have to use AWS Lambda functions, one of the ways to actually deploy Lambda functions is by using Docker images. Otherwise, there are few restrictions. Okay. So those who have any follow-up questions, who want to sign up for the course, you guys can send an email to support@itversity.com. Make sure you have relevant subject so that our sales staff can connect with you and take it further. Okay. And also, Abhijit Sahu, on top of Docker and Kubernetes, he also have additional question. How CI/CD integrated into data engineering workflow? You explained, is CI/CD essential for data engineers? See, when it comes to software engineering, data engineering, and DevOps, these three are specialized roles. As a software engineer, as well as a data engineer, you should know how to integrate or how to interact with the CI/CD pipelines or the teams which is taking care of the CI/CD. So there will be some interface between the two. I'll be touching those points as part of our guided programs, but you don't need to master CI/CD. It is not essential skill for the data engineers. You can focus on core data engineering. Once you start deploying some applications, you will understand the relevance of CI/CD from the data engineering perspective. You don't need to even have CI/CD and all as part of your profile. If you are aiming to be an architect, then probably you should spend some time around not only CI/CD, but the overall best practices to implement the data engineering solutions in a robust manner. It includes code review and all those things. So you have to highlight those aspects as well. Ronak is asking, labs are available with guided programs. Only up to Python, SQL, and Spark will be providing the lab. When it comes to AWS, you have to use your own account. We'll not be able to provide the lab for AWS related stuff. Hardly it will take $50 to $70 to go through the content with respect to AWS, unless you make some serious mistakes at the time of learning. I hope I answered most of the questions. Thank you very much for attending the session. Once again, I'm reiterating, if you haven't subscribed to our channel yet, make sure you subscribe and also click on the notification icon. And also make sure to like and also share with your friends in case if anyone is interested. This will give a comprehensive overview about data engineering, and also we'll be going to the workshop. They will know what it is actually, so that they can make a wise decision or informed decision. Okay. So we will catch up again tomorrow. If you are not familiar about tomorrow's session, again, you can sign up, subscribe to our channel, you will get the notification. Also, as part of the description, I will update the link with tomorrow's session as well, so that you can join tomorrow. Okay. So one last question which I will take from Rock. Sir, we need a couple step-by-step roadmap for data engineering. What are the tools we need to learn, please? So that is what this entire session is. I think you might have joined a little bit late. You have to go through this entire live streaming session, and also you have to join tomorrow's session to understand the complete roadmap. Okay, so go through this entire session, and if you have any questions, feel free to post it in comment or join the tomorrow session and ask the question in tomorrow session. That being said, I'll be wrapping up for today. Thank you very much for your patience, and sorry for the initial hiccups with respect to launching the session. We'll catch up tomorrow. For now, I'm wrapping up. Any follow-up questions, feel free to post in comments. I will respond whenever I get time. Thank you. Bye.